Remember how I would ask you, is there a way that we can add these two equations together right now and eliminate one of the variables? What would your answer be to that? Yes or no? If I add them together right now, I get 6x plus 13y. I did not get rid of either variable. So that's a definite no. What should I multiply the bottom equation by so that I could get rid of the x's? Negative 5 would be an excellent choice. Okay, so that would give me negative 5x minus what? 35y equals negative 175. If I were you, I would add those two equations together. Add those two equations together. Of course, my 5x's would be gone. What is 6y plus negative 35y? Negative 29y. Wait, what? Okay. And then 1 plus negative 175. What's 1 plus negative 175? Negative 174. So, what is the value of y? 6. Okay, find the value of x. I suggest you use one of the previous equations to do the value. Now that I've got the y value is 6, how do I find the x value? Plug in y. Alright, do you have a favorite equation that you want me to use? The first one? Okay. Oops. Lock it in. The first one. Alright, so 5 times x plus 6 times 6 equals 1. Alright, so I'm going to subtract 36 from both sides, giving me 5x equals negative 35. So now what? Divide by 5, what do I end up with? Negative 7. What's the answer to my question? Negative 7 comma 6. It is extremely important that you answer the question. I'm looking for a coordinate in the universe. What are these two equations? What do they represent? We talked about it last week. They are both what? Lines. And those lines could cross one time, they could cross no times at all, or they could be the same exact line and cross an infinite number of times. This one crosses one time. You better be able to tell me where that place is. Okay, let's see what's next. So far I think we got everything there, good. Can we add these two equations together right now and get rid of one of the variables? Okay, do it. Add them together. It shouldn't be that difficult for you. Find the coordinate where they cross. Find the coordinate where they cross. So hopefully you added them together, got 8x equals 8, divided out the 8, found out that x was 1. Which equation? Is there a particular equation that's easier than the other? No, not really? Okay. So if I picked one of them, 4 times 1 plus 7y equals 4. Subtracting that to the other side gives me 7y equals 0. What does that mean? The only number in the universe which would make that true is 0. So y does equal 0. So 1 comma 0 is your answer. Now, we're going to come across some other situations here in a second where 0 is going to be involved, but it doesn't mean that the y value or the x value equals 0. You'll see what I mean when we get there. Okay? But in this case, the y value did end up being equal to 0. So those two lines crossed in one spot. What would you multiply the bottom equation by? What would be the easiest number to multiply the bottom equation by to get rid of the y's? 4, positive. Okay. So 12x minus 4y equals 36. Leave the top equation alone. 2x plus 4y equals 20. Go from there. Shouldn't take you too much time to get this, since we've been doing it a bunch. Okay, when you added them together, you got 14x equals what? You added these together, you got 14x, right? These things canceled out, and that left me with 56 on the other side when you added those. Okay, so what does x equal? X is equal to 4. Mr. Martin, did you have a favorite equation you wanted to plug it back into to find the y value that went with it? All right, we'll do that first equation. 2 times x, well, that's 2 times 4. Okay. Plus 4y equals 20. All right, so let's see here. Let's take away 8. Get rid of that. 2 times 4 is 8. So now that's 12. How do I... 4 and 4. Okay, so what do we get for a y value? 3. So we have 4 for x and 3 for y for our coordinate. Any questions on what we were doing there? Very similar to what we did on Friday. Okay, your turn. Go. So you added them together. What did you get on this left side? You got 0. What did you get when you added 7 and 7 together? 14. I did see a couple of you say 7. Okay. Okay, but I'm sure you know. Okay, here's a multiple choice question for you. Your answer choices are always sometimes or never. When in your life has 0 been equal to 14? Always, sometimes, or never? Never. What does that mean about these two lines? These are both lines. Remember the 3 different types of line systems. One where they cross one point. One where they don't cross at all because they're parallel. And one where they're the exact same line. Which one do you think this goes with? You told me 0 is never equal to 14. So this is never true. Do you think that goes with a situation where they cross one time, they never cross at all, or they're the same exact line? They never cross. This is an inconsistent system. Ooh, I can't spell. Oh, I'm okay. We've got parallel lines here. So the answer to my question, no solution. We'll skip 10 for the moment and come back to it if we have a chance. The reason we're going to skip 10, and I'll show you why. Which variable do you want to get rid of? Just pick one. Okay, let's say we want to get rid of the x, all right? The smallest thing I can think of that 7 and 8 both go into is 56. So I would be multiplying one equation by 8 and the other equation by -7. I'm going to get some decently large, maybe this isn't as bad as I thought, okay? So it's not as bad as I thought. What do we got there? 56x minus 64y equals -160 and -56, negative 216, I believe. And then negative 56x minus 49y equals negative 420 minus 42 negative 462. Is that right? Yes. All right. What? What are you impressed with? How do I know what? Oh, you're talking about National Joint Variation Day. Jeez, seriously, you people. It's a big Algebra 2 holiday. But, you know, we haven't talked about joint variation. That'll be second semester. Anyway. It's where we celebrate all the directly related variables. It's true. Alright, see if you can come up with your solution to this. If there is one. Well, and hopefully you came up with a y value of 6. Awesome. So then we can pick our favorite equation. Let's see here. Mr. Marks, which one's your favorite equation? Okay, go with the bottom one. 8x plus 7 times 6 equals 66. Of course, we're going to subtract 42 because 7 times 6 is 42. So, hey, you know what? That is good reasoning. I do the same exact thing. Don't ever let anybody make fun of me for that. 24. Okay. And then, of course, what would you do to get x by itself? Divide by 8. Okay. So x is 3. So what's the answer to my question? 3, 6. Thank you very much. 3, 6. Okay, question 11. Go. Question 11. For the last one, we ended up getting 3 when we divided by 8. Think about what you need to multiply by so that you can get rid of one of the variables. Which variable do you want? You want to get rid of x? So what did you multiply the top equation by? I would go with -2. So I would get -6x minus 4y equals -6. And now I'm going to add these two equations together. Well, the x's cancel, and the y's cancel. That leaves me with 0 on the left side. And what do you get when you add -6 and 0 together? -6. What does this mean? It's never true, right? And if it's never true, as we talked about a few minutes ago, that means we're talking about the no solution situation. Now, sorry. Any questions about that? Yes? Is there a question? Okay. All right, now, I'm going to make up one more example for you, so write this down in the blank space somewhere. Yes! Mm-hmm. Okay. Use your elimination and solve it. Definitely not. Okay, so what'd you multiply the top equation by? Probably 2, right? And you got 6x and 4y and equals 24. And then you thought, okay, I'm going to add this equation and this equation together. Right? And what happens to the x's? Gone, right? And what? And you're happy about that, right? And then the y's? Also gone, right? So that gives me 0 on the left side of the equal sign. And what happens on the right side of the equal sign? 0. We need to understand what this means. Remember, I gave you a multiple choice question earlier. I said the answer choices were always, sometimes, or never. Is this true? Always, sometimes, or never? This is always true. Now, if it's always true, what type of situation are we dealing with? Are we dealing with lines that cross one time? Are we dealing with parallel lines that never cross? Or are we dealing with the same line that has an infinite number of solutions? Infinite number of solutions. Okay? So, infinite number of solutions. This is the magic situation which happens for that. If I get 0 equals 5, I know that's never going to happen. They're parallel lines. But if I get 0 equals 0, that's always true. Anyway, I thought I would bring that example to your attention since we hadn't seen one of those yet. Okay, so that would be the last example.